Hey everybody, Mr. Kowalczyk here, just jumping into Geometry Unit 4, Lesson 2, the converse of the Pythagorean Theorem. And before we start this, what we're going to do today is we're going to say I can use the Pythagorean Theorem to classify a triangle as acute, right, or obtuse. Remember, classify means name it and decide what kind of a triangle it's going to be. Before we jump into that, let's just go ahead and review briefly what the Pythagorean Theorem actually is. It's used with right triangles, typically. And we're going to use the general idea of the Pythagorean theorem today in classifying this. So the Pythagorean theorem is used with right triangles, where we have a right triangle that's got a right angle here. And the side opposite that, as we learned before, is called the hypotenuse. And then we have a leg here and a leg over there. Any right triangle this will work with, whether it's acute or, whether it's scalene or isosceles. So in this situation, the rule for this is going to be the hypotenuse squared. The length of the hypotenuse squared is equal to the length of the leg squared plus the length of the other leg squared. What you may have seen it written as differently might look like this. Let me get another color here. So we may have seen it, you may have also seen it as this leg could be referred to as A, this leg could be referred to as B, and the hypotenuse is referred to as C. So we have C squared equals A squared plus B squared. So you may have seen this before in order to understand it as the Pythagorean theorem. All right. So now what we're going to do with this opener is we're going to use the Pythagorean theorem to solve for the missing side. So in this situation, what you're asked to do is assume that the angle that looks like a right angle is a right angle. So about right here, right? So this one is going to be a right angle, this one will be a right angle, and so on throughout the whole page. Round to the nearest whole number. Use the space underneath if you need more room. So down here at the bottom of the page, there's some extra space there, okay? This is definitely calculator stuff. So I recommend you get out your calculators and you use them in order to solve for the Pythagorean theorem. Let me get the glare off my calculator here so you can see what I'm doing. That's not helpful. Oh, yeah. All right, that works a little bit better. Okay, so what we have here is we've got our two sides of our right triangle. So in this case, this is our hypotenuse because it's across from the right angle, or we also call it C. And then we're going to have A and B. Okay, so I'm going to plug this into my Pythagorean theorem, where I'm going to have A squared plus B squared equals C squared. In this situation, A is going to be 17 plus B squared, because I don't know what B is, that's my question mark, and that's going to equal C squared, which is 41 squared. Now I'm going to get my calculator, and I'm going to do 17 squared, or 17 times 17, and that gives me 289 plus B squared equals 41 squared, and that's 1,681. Okay. Now I'm going to subtract 289 from both sides to get B squared. And that's going to give me 1,392. Now, in case you forgot, the operation on our calculators in order to undo a squared, because we have B squared equals 1,392, is this button right here. You see that square root symbol? It's above the square, the x squared sign. It's right there. It's light blue. So I'm going to tap that and hit the square root of, and then this number of 1,392. Okay, that's how I undo squaring something. And then this is going to give me 37.3, which is going to round to about 37 in this situation. Okay? So this is how you're going to solve each of these 6 different Pythagorean theorem problems. Let's do one more together. Let's do number 6, because in number 6 we don't know what the hypotenuse is. All right, so we have 22 and 47. So again, in this situation we have C, and our two legs are A and B. A squared plus B squared equals C squared. 22 squared plus 47 squared equals c squared. All right, so now with the calculator, 22 squared equals 484 plus 47 squared equals 2209 or 2209 equals c squared. Now I add those together, 484, and I get 2693. Oh, I'm off the page here, sorry about that. 2693 equals c squared. Now I want to get rid of this squared, so I'm going to square root both sides. And that means I have to do second square root 2693. And that's going to equal c is about, and this is 51.89, which is going to round up to 52, because 51.89, the 0.8 is greater than 5. So c is about 52. So the side of this triangle is about 52, which makes sense based on how it looks, right? 22, 47, and 52. All right, now please pause the video. Go ahead and do 2, 4, 3, and 6 by yourself to try to figure out what you can get for each of these missing sides in these right triangles. Okay, so hopefully you went ahead and did all of those Pythagorean theorem practice problems. Now for today, what we're going to do is we're going to start with this exploration table. And I'm going to show you how I want you to fill it out by doing the first 2 examples with you. And then I'm going to ask you to fill out the next 3 examples on your own. So what we're going to do is we're going to use this idea of the Pythagorean theorem where we have a squared plus b squared and c squared. And then in our third column, we're going to compare a squared plus b squared and c squared, whether or not they're equal, less than, or greater to one another. Okay, so first off, what I'm going to do is I'm going to color code. A squared plus b squared are going to be our legs, and those are going to be our shorter 2 sides. Okay, and in this case, 65 and 72 are going to be the shortest 2 sides. Now, c squared is going to be our longest side for the whole table all the way down. So that means that 97 is going to be the longest side. So what we're going to do now is we're going to sort out through our calculator 65 squared plus 72 squared. We just want to get that down to one number. And then we're going to compare that to 97 squared. Okay? So let's go ahead and jump in with our calculators. We're going to do 65 squared is 4,225 plus 72 squared is equal to 5,184. Now we add those together and we get 9,409. Then we do 97 squared, and that's going to give us 9,409. Okay, so now what we're trying to do is how does a squared plus b squared compare to c squared? Is it equal, less than, or greater than? Well, they're equal to each other. Okay, that's all we're doing for now. We're not evaluating or judging what this means. We're just looking at what that is. Okay, how they compare to each other. Now, for this one, we've got a funky number here. So I want to take a minute and just point out what's going on. This number right here is 4 times the square root of 19. And then we have 14 and we have 10. Now 4 times the square root of 19. The square root of 19 is just a number. And we take that number and we multiply it by 4. So what I told you earlier was that we need to figure out which are the shorter 2 and which is the longest side. So we have to use our calculator in order to determine which of these is the longest side so we can put it in the c squared column. So let's go ahead and do that. So using our calculators, we're going to go like we did earlier with second square root of 19. Now our calculator tells us that's about 4.358. All right, that's all we need to know for now. But in the triangle, that 4 times the square root of 19 is multiplied. So we're going to have to take our calculator, and what we can do on some calculators is we have this button down here that has ANS. That means answer. And it means the answer from the previous problem, this 4.35 number. And I want to use it as exact as possible. And I'm being a little bit lazy because I don't want to type that whole big long number back into my calculator and then multiply it by 4. So what I'm going to do is I'm going to push the second button, which is my light blue button, and then the answer button. And that means this answer right here. That's one line up from that. Then what I can do is I can multiply that by 4, because this number right here, this 4.35 number, is the square root of 19. And we want to multiply it by 4 because that's this side of our triangle. Okay? So this means 4.35 blah, 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 times 4, and that equals 17.43. So I'm going to write that in here just as a visual reminder for myself, 17.4. And I know it's more than that, but it just helps me figure out which is which. Okay, so now using our color coding, clearly 17.4 is the longer side of the triangle, and I had to make sure of that. I couldn't just use the visuals because we remember that the triangles aren't always drawn to scale. And then 10 and 14 are going to be my A and B sides, the shortest sides in that particular triangle. So now let's go ahead and do our math. So we have 14 squared plus 10 squared, and then over here we're going to have 17.4 squared. So let's use our calculator. 14 squared is equal to 196 plus 100. 10 squared is 100. Hopefully you know that. This is going to be 296. And then 17.4 squared. And I'll type in a couple more numbers so it's more exact. 3,559,577. And then we square that. And then we get 303.9. So I'm going to round that up to 304. Okay. Now, what symbol would go in between these two numbers? Equal, less than, or greater than? Well, if you remember, the symbols are going to be wanting to, if we think of it as a mouth, it's going to want to eat the larger number. So which is greater? Well, a squared plus b squared, or a squared plus b squared is going to be less than c squared. So the mouth is going to eat the 304, and the greater number is going to be over here. If you would prefer, you can definitely write the numbers in. So you can put your pink column here for c squared. And you can put your green numbers on the other side here, if that makes more sense for you. So in this case up here, it will be 9409 is equal to 9409. And in here we have 296 and 304. So that the greater than symbol is going this way. Oh, I'm off the camera. Sorry about that. Okay. So this is how we did the first two. What I want you to do is now do the next three on your own and compare these. Right now, hopefully you finished up the table A-OK, and your results jive with mine. Jive is an old-fashioned way of saying agree with, just in case you didn't know that. Fantastic. All right, let's get in focus here. So what we've got is we have an equals, we've got a less, a greater, less than, greater than, and equal to. What I want you to notice, and I don't remember if I said this at the beginning, these triangles are drawn to scale. So what we want to do is we want to compare and see if we can come up with a rule down here for classifying triangles using the Pythagorean theorem. So what we notice is that in the relationship, if a squared plus b squared is greater than c squared, that means that the triangle in this case is going to be acute. Now notice there's no right angle. C squared in this situation is just the longest side of the triangle. In this case, if we have a squared plus b squared equaling c squared, then we're going to be in a situation like this where that's a right triangle. And in this case, the Pythagorean theorem works, meaning it's equal, the relationship is equal, so we have that right angle. And then, of course, in this final situation, we have a squared plus b squared being less than c squared, and that's going to be an obtuse triangle. So this table here at the bottom of this page is going to be really helpful for the rest of the lesson in terms of classifying your triangles. We want c squared to be the longest side in each of our testing situations, and then we add the other two sides squared together and compare them, whether they're greater than, equal to, or less than c squared, in order to determine what type of a triangle we have. Let's try a couple of these problems together, and then you can go ahead and finish up the independent practice in class. All right, now on our next page, we're going to jump in and do number 1 together. Now, this is similar to what we were just doing, but we're going to try to use the results in order to determine what kind of triangle we have. Okay, so like my color coding, 16 is going to be my longest side, and 9 and 12 are obviously my shortest sides. So now I'm going to have 9 squared plus 12 squared. And how does that compare to 16 squared? Okay, so that's going to be 81 plus 144. And I've forgotten off the top of my head what 16 squared is. Let's go ahead and do that. 16 squared, 256. That's right. Okay, how does that compare to 256? 81 plus 144 is going to give me 225. How does that compare to 256? In this situation, 256 is greater. So then I go back to my table, and I look at my table, and in which situation do we have here? So let's get these organized in the camera. Since I can't just go back and forth, which situation do we have? Well, in this case, c squared is greater than a squared plus b squared, so that's going to point us to this situation here, and we're going to have an obtuse triangle. And that's the answer that we're looking for. Okay? Go ahead and do wait to do 2 through 8 during independent practice. And as you see, there's some square roots here, so you're going to need to figure those out on your calculator. What are those side values worth? Okay. Now, in this situation, on the next page, I'm going to do one more, and we don't have a particular triangle side, or a drawing of a triangle diagram. We have the 3 sides here, but we don't have the diagram. So we know that 13 is going to be our c squared because it's our longest side, and 5 and 12 are going to be our a and b squareds. So let's go ahead and solve this one. So we have 5 squared plus 12 squared, and how does that compare to 13 squared? 25 plus 144 compared to 169. 5 plus 4 is 9, 2 plus 4 is 6, 169 compared to 169. Well, of course, those are equal to each other, and that's going to give us a right triangle based on our table. All right, now one more. We'll try to solve this one together and see what we can get. Now, again, I know how big 9 and 13 are, but I don't know how that compares to 2 root 22. So on my calculator, what I'm going to do is I'm going to type in 2 and then second square root 22, and then just hit enter. And that's going to be 9.38. So how does that compare to each of these? Well, it's in between this. So then 2 root 22 is going to be about 9.38. So that means my 2 shortest sides are right here, and my c squared is going to be right there. Okay, so we have 9 squared plus 2 root 22 squared. And how does that compare to 13 squared? Well, we know 13 squared is 169 from the previous problem we did. Oops, not squared. And how does that compare to this stuff here? Well, 9 squared we know is 81 plus, let's do 2 root 22 squared in our calculator. Because we have 2 root 22, the answer right there, I can do second, and then that answer button right down there. So I have my answer, and then I just square it. And that gives me 88. All right, so 81 plus 88, that's going to give us 8 plus 1 gives us 9. 8 plus 8 gives us 16 compared to 169. And again, they're going to be equal to each other. So that's going to be a right triangle. Okay. All right, so let's go ahead and play with the rest of these in class tomorrow. That's all that I wanted to do for the video. Have a great day, and we will see you in class.